Hey kiddos, this is the video for home connections 15 and 16. Number 1, draw and label a rectangular array to show 2 factors for each number. Do not use 1 as a factor. Then write the fact family that goes with each array that you draw. The factors of 8, 1 times 8 equals 8, 2 times 4 equals 8. And they said right in the directions not to use 1, so they drew an array that was 2 by 4. The factors of 16, 1 times 16 is 16, 2 times 8 is 16, 4 times 4 is 16. And you can list 4 once or you can list it twice. They said not to use the factor 1, so I'm not going to do an array that's 1 by 16. I think I'm going to do an array that's 2 by 8, because 2 times 8 is 16. Okay, 2 by 8. So 2 times 8 equals 16 would be the first part of my fact family. 8 times 2 equals 16. 16 divided by 8 equals 2. And 16 divided by 2 equals 8. If I chose 4 by 4, because 4 times 4 is 16, my fact family would be really quite repetitive. It would look something like this. 4 times 4 equals 16. 4 times 4 equals 16. 16 divided by 4 equals 4. And 16 divided by 4 equals 4. That's one of the reasons I chose the factors 2 and 8. Okay, and the last one, the number 18. The factors of 18. 1 times 18 is 18. 2 times 9 is 18. 3 times 6 is 18. They said not to use 1, so you could either have an array that was 2 by 9 or 3 by 6. If your array was 2 by 9, your fact family would be 2 times 9 equals 18. 9 times 2 equals 18. 18 divided by 9 equals 2. 18 divided by 2 equals 9. It's okay if it's not in the same order as Mrs. Judson wrote. You also could have an array that was 3 by 6. And your fact family might be something like this. 3 times 6 equals 18. 6 times 3 equals 18. 18 divided by 6 equals 3. 18 divided by 3 equals 6. Number 2. List all the factors for each number. Letter A, number 16. 1 times 16 is 16. 2 times 8. And 4 times 4. Again, you could list the 4 once or list the 4 twice. Letter B, the factors of 17. 1 times 17 is 17. Letter C, the number 24, there are a lot of them. 1 times 24, 2 times 12, 3 times 8, 4 times 6. The number 9. 1 times 9 is 9. 3 times 3 is 9. And the number 36. 1 times 36 is 36. Because it's even, I know that 2 will work. 2 times 18. 3 times 12. Does 4 work? Yes, 4 times 9. Does 5 work? Let's see, 5 times 7 is 35. Does 6 work? Yep, 6 times 6. Does 7 work? No, 7 times 5 is 35. 8, let's see. 8 times 4 is 32. 8 times 5 is 40. Does 9 work? Yes, 9 works. 9 times 4. And 9 is already up there. That's when you know you have them all. Okay, looking at number 3. Number 3 says, circle the prime numbers. Remember, a prime number has only 2 factors, 1 and itself. So the number 17 is totally a prime number. Because it has two factors, 17 is a prime number. 1, 2, prima donna. Letter A says draw a square around the square numbers. We'll talk more about this as the year progresses, but a square number, if you can make a square array, it is a square number. So the number 9 is a square number because I could make an array that was 3 by 3. The number 16 is a square number because I could make an array that was 4 by 4. And the number 36 is a square number because I could make an array that was 6 by 6. Another example would be the number 100. 100 is a square number because you could make an array, it has factors, 10 by 10. All right, on to page 2. At the end, I'll show you all of the answers. Number 4, is the number 25 prime or composite? And how do you know? 25 is composite because it has more than 2 factors. Remember, prime numbers have 2 factors, 1 and itself. So the definition of composite would be it has more than 2 factors. And you could list the factors as well. 1 times 25, 5 times 5. Again, you could list the number 5 once. You could list it twice. But sometimes I think listing it once is more accurate because the number 25 really only has 3 factors. Because you wouldn't count 5 2 times. But regardless, no matter what, 25 has more than 2 factors, so it is definitely a composite. Number 5, Judy has a collection of 30 stamps. She can divide the stamps into 2 equal groups of 15 stamps. What are 2 other ways she could divide the stamps into equal groups? They're asking us for the factors of 30. 1 times 30. 30 is even, so I know 2 will work. 2 times 15, 3 times 10, and 5 times 6. Okay, so you might have written something like this. They said in the problem 2 groups of 15. So I don't know if anybody would do this, but I suppose here would be an option. 1 group of 30 or 30 groups of 1. Okay, so 1 group of 30 or 30 groups of 1. You could do 2 groups of 15, which is what they said, or 15 groups of 2. I'll just write them both down. 2 groups of 15 or 15 groups of 2. Okay. You could do 3 groups of 10 or 10 groups of 3. 3 groups of 10 or 10 groups of 3. You only had to write 2 other ways. I'm writing quite a few other ways. Okay, and the last one, 5 groups of 6 or 6 groups of 5. 5 groups of 6 or 6 groups of 5. Imagine having 30 tiles, those little plastic tiles we used in class, and arranging them into all the different arrays that you could possibly make with 30. And the last one, the challenge question. Come up with as many factors of 96 as you can. There are so many of them, and these are factors that not very many people have memorized. Here are all the factors of 95. If you even got some of these, good for you. 1 times 96, and you don't have to put them in order. You could just pair them up. 96 is even, so I know 2 will work. 2 times 48. I can divide 9 by 3 and 6 by 3. So I know 3 is going to work. 3 by 32. 4 will work. 4 by 24. 6 will work. 6 by 16. And 8 will work. 8 by 12. Let's make a super exciting factor rainbow here. Okay. 1 times 96. 2 times 48. 3 times 32. 4 times 24. 6 times 16. And 8 times 12. All factors of 96. Okay, somewhere under the rainbow, factors fly. To get a product, they're the numbers that we multiply. So these are all the ways that you could make 96. Okay, here are all the answers for home connections 15 and 16. Okay, kids, I will see you in class.